This is lecture number 4, a preview of what is to come in the lecture itself. So we trust you will find this to be quite illuminating. We're going to give you some hints on how to handle some of the problems that will be appearing in lecture number 4. So please follow along. The main idea in lecture number 4 in the Einstein maths program is the theory of probability. You must have heard of this before. Probability means the chance of something happening. What is a chance of a certain type of event might happen, such as a weather phenomenon, and so on. The probability that it will rain. Now, the way we work out the probability is to know how many different possibilities there are and how many are the ones that we want or that will work. For example, what is the probability you will be 1 day older tomorrow? Well, it's 100%, isn't it? So we say the probability is 1. Or we can say 100%. If something is a certainty, it has a probability of 1. What is the probability you will be dry if you jump into a pool? 0. You must get wet. So it's 0%. So all probabilities are between 0 and 1. Okay? So if you try out some of these problems, you will find them to be a bit easy first. Find the probability of being born on a Monday. That's how we write it. P brackets being born on a Monday means probability of being born on a Monday. Now, how many days are there in a week? 7. How many Mondays are there in a week? 1. So the chance of being born on a Monday is 1 out of 7. Okay, are you getting the idea of a probability? What is the probability of being born on a day starting with S? Well, how many days are there in a week? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. How many of them start with an S? 2 out of 7. So the probability is 2 out of 7. Okay, you can try the rest of it and we will consider them in class. Under the problem solving, with regard to a person's birth date, what is the probability of being born in March? Well, there's only one March in a year of 12 months, so the probability is 1/12. How about being born on a Tuesday? Well, it's 1 day out of 7, isn't that so? So that's 1/7, and so on and so on. So you try the rest there. A die is rolled. What is the probability of getting a 3? There's only one 3, and there are 6 numbers, so the probability should be 1 out of 6. A die, or what people call a dice, has got 6 numbers, as you can see, 1, 2, 3, 4, 5, 6 on each of the faces. What's the probability of getting a 6? There's only one 6, and there are 6 numbers, so it's 1/6 also. What's the probability of getting a number more than 6? The highest number is 6, so the probability is 0 out of 6. Right? I think you're getting the idea now. So let's leave the rest of them out for you to try out. I think you do understand how they work. Think about these coins problem. 3 coins are tossed. What is the probability of one tail only? So remember, when you toss a coin, you can either have a head or a tail. If you have 3 coins that you're tossing, you can have head, tail for each one, but then you can have many combinations. So one combination is head, head, head. You could have head, head, tail. How many combinations are there altogether? And amongst those, which one has got one tail only? You find it out. Okay. Number 6, you have a full deck of cards. Remember, a deck of cards has got 52 cards in it, and there are 4 suits. In case you don't know much about cards, there are spades, diamonds, hearts, and clubs. What is the probability of getting an ace of clubs if you draw 1 card? Well, there's only one ace of clubs, so it's 1 out of 52. Okay? All right, now you consider the rest yourself. Moving on, counting methods. Jane has a certain number of skirts and blouses as shown in the table below. In each case, how many outfits can she make up? Suppose she has 3 skirts and 2 blouses. Let's say she has a red, blue, and green skirt and two blouses, pink and white. So pink and white can go with the red, pink and white can go with the blue, pink and white can go with the green. So how many combinations are there altogether? 1, 2, 3, 4, 5, 6. 6 combinations. Do you think there's an easy way to get 6 using a 3 and a 2? What do you think? Good. So you figure that out, and we will discuss that in the lecture. Now that we have learned that idea, suppose you have 3 letters, M, N, and P. How many 3-letter words can you make if letters may not be repeated? Okay, so you have 3 letters, 3-letter words. So that it could either be an M, an N, or a P. So how many combinations are there for the first block? 3. It could either be an M, an N, or a P. M, N, or P. Now you're not allowed to repeat. So how many left do you have for the second block? Only 2, because once you have chosen one of these 3, you have only 2 left. And once you chose those 2, how many are left for the last block? Just 1. So according to the previous rule that we have learned there with the outfits, the total number of combinations will be, okay, we will discuss that in the class. What if you're allowed to repeat? Then there's 3 combinations for the first block. You still have 3 for the second block and 3 for the last block. So how many altogether? Right, we'll consider that in the lecture. Problem solving. Next one, you have 4 letters this time, A, B, C, D. How many different 4-letter words? So we're going to repeat the same idea. I think you have got the idea now. And so let's move on to, I think those ones are fine, they're manageable. A bag has 4 red marbles and 6 blue marbles. 4 red and 6 blue. What is the chance of picking up 1 red marble? Well, there are 4 ways of getting a red marble out of 10. So the chance is 4/10 or 2/5. Picking up 2 red marbles without putting the first one back. Now this one is a surprise and will be much harder than the first one, but we will discuss that in the class. Okay, you can handle the dice problem again. The horses problem you can discuss yourself. Different combinations of the cricket team, you can handle that. Look at the dart board. You throw a dart, find the probability of getting a multiple of 2. Right, multiples of 2 are like 12, 10, 14. There are 3 numbers there, so there's 3 out of 6 altogether. So it's half. Okay. You try out the remaining ones and we'll consider them in the class. A lady is in a TV game show. She's given 2 black marbles and 2 white marbles. Let me color that. Well, these are purple marbles, but you know the idea. And now there are 2 boxes. The lady is blindfolded. Her husband is blindfolded. He must pick up a marble from any box, and if it is white, they win the grand prize. How should she place the marbles to maximize their chances of winning, to get the greatest possible chance of winning? And you think about all the possible combinations you could have. You could probably have black, black, white, white, black, white, white, black. Doesn't matter what the order is. Or you could have black, white, white, black, or white, black, white, black. So these are the various combinations you can have. Now, which ones will give you the best? Or you could have nothing here, and you can put them all into one box. Black, white, black, white. But the danger is that you can pick the first box, and if you do, then you get a 0 prize. Good, so that's quite interesting, and we look forward to discussing that together in the lecture. I will see you in the lecture proper.